Hello students, I am Harsh Gupta, the today's maths faculty. I hope you all are doing well in your school and in your life. Students, our today's topic is quadratic equation. In our today's lecture, if you have any type of doubt, you can ask me your doubt in any of the two languages, English and Hindi. So let's start our today's topic, quadratic equation. So, before reaching to our main topic, quadratic equation, first, let's define polynomial. What is polynomial? An expression in the form of a0 plus a1x plus a2x square plus dot 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 an x to the power n is equals to px is called polynomial of degree n, where a0, a1, a2, dot 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 an are real numbers and n belongs to natural number. I repeat again, an expression in the form of a0 plus a1x plus a2x square plus dot 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 plus an x to the power n is equals to px is polynomial of n degree. Okay. What is quadratic polynomial? A polynomial whose degree is 2. A polynomial whose degree is 2 is known as quadratic polynomial. Okay. Now let's define what is quadratic equation. Okay. So an equation in the form of ax square plus bx plus c is equals to 0 if quadratic equation if a comma b comma c it belongs to real number and a not equal to 0. Students, if a becomes 0, then our whole equation becomes linear equation. Okay? Therefore, here a should not be equal to 0. Okay? Now, here is the example: x square minus 5x plus 6 is equal to 0 is quadratic equation. Here a is equals to 1, b is equals to minus 5 and c is equals to 6. Okay. Now, what roots of quadratic equation? Students, roots are basically the value of variable x for which our given equation becomes 0. For example, let alpha be a real number. Alpha is said to be root of quadratic equation ax square plus bx plus c is equals to 0 if a alpha square plus b alpha plus c is equals to 0. Then we say that alpha is the root of the quadratic equation ax square plus bx plus c is equals to 0. For example, we have x square minus 5x plus 6 is equals to 0. So, put x is equals to 2. We have 2 square minus 5 into 2 plus 6 is equals to 0. So 4 plus 6 minus 10 is equals to 0. So therefore x equal to 2 is the root of our given quadratic equation x square minus 5x plus 6 is equals to 0. So our next topic is relation between roots and the coefficient of quadratic equation. Students, let our given quadratic equation be ax square plus bx plus c is equals to 0. If alpha and beta are roots of quadratic equation, then alpha plus beta is equals to minus b by a, and alpha into beta is equals to c by a. Sum of the roots is equals to minus of coefficient of x upon coefficient of x square, and product of the roots alpha into beta is equals to constant term upon coefficient of x square, c by a. For example, x square minus 5x plus 6 is equals to 0. Here 2 and 3 are roots. Now 2 plus 3 is equals to minus b by a, means 5 by 1, and 2 into 3 is equals to c by a, means 6 by 1. Okay, now let's reach to our next point, writing the quadratic equation when its roots are given. Let alpha and beta be the root of quadratic equation. Then our quadratic equation can be written as x square minus of alpha plus beta into x plus alpha into beta is equal to 0. The quadratic equation can be written as x square minus sum of roots into x plus product of roots is equal to 0. So this is our required quadratic equation. For example, if we have 4 and 6 as root of a quadratic equation, then our quadratic equation can be written as x square minus 4 plus 6 sum of the roots into x plus product of roots is equals to 0. X square minus 10x plus 24 is equals to 0 is our required quadratic equation. Now we are going to find the roots of the quadratic equation. Okay, so let our quadratic equation be ax square plus bx plus c is equals to 0. To find the root of this equation, we use quadratic formula named Sridharacharya formula. See how? D is equals to b square minus 4ac, where d is known as discriminant. And so our roots are x is equals to minus d plus minus root d on 2a, where b is the coefficient of x and a is the coefficient of x square, and c is the constant term of quadratic equation. For example, if we have x square minus 5x plus 6 is equals to 0, our given quadratic equation. Now by using quadratic formula, d is equals to b square minus 4 into a into c. 25 minus 24 is equals to 1. So d is equals to 1. Now the roots are x is equals to minus b. So minus b means 5 plus minus root d means 1 upon 2a. Here the value of a is 1 upon 2. So 5 plus minus 1 upon 2 is equals to x is equals to 2 and x is equals to 3. 2 and 3 are the roots of our given quadratic equation x square minus 5x plus 6 is equals to 0. Nature of roots. The nature of roots are totally depend upon discriminant d. If we have the quadratic equation ax square plus bx plus c is equals to 0, if we have to find the nature of roots of this quadratic equation, whose discriminant is equals to b square minus 4ac, if d is greater than 0, then roots are real and distinct. If d is equal to 0, then roots are real and equal. If d is less than 0, then roots are complex. Without solving, what is the nature of roots of our given quadratic equations? First, 2x square minus 5x minus 4 is equals to 0. So, discriminant here is b square minus 4a into c. So, 25 plus 32 is equals to 57, which is greater than 0. Here, roots are real and distinct. Now, for this, d is 7 square minus 4 into 3 into 8. 49 minus 96 is equals to minus 47, which is less than 0. Here, roots are complex. Now, for this equation, 9x square minus 6x plus 1 is equals to 0. d is minus 6 square minus 4 into 9 into 1. 36 minus 36 is equals to 0. Here d is 0. Here in this case, roots are real and equal. Okay students, thank you for today's session.